Okay, great. So, yeah, good morning and thank you for the time and for all of you for listening. Yeah, we were asked to come in and chat just a little bit about um, soil moisture sensors and some of the ways they can be used in the field. And so I'll touch on this. It's a like a lot of things. It's a deep and robust topic, but I will try to touch on some of the key points, some of the things that we keep in mind when we utilize them, and then um, if we have time, take any questions you may have. So I guess just for some background, so um, I run a program called the Agricultural Water Quality Program. We focus on working with producers on best management practices to protect water in the state of Colorado, and primarily our focus is keeping agricultural chemicals, pesticides, and fertilizers out of water in the state of Colorado, and working with producers on ways to do that. And so for us, irrigation water management is a big important part of that for us. Working with, we can in an irrigation dominated system that that we have in most of the state of Colorado. We can manage our fertilizer as best we want to, but if we don't manage our irrigation water well, we can still lose some of the things that we don't want to move off farm and off site in fertilizers and pesticides. So that's kind of what I do as a background. So first couple slides here, I just wanted to show a couple of points. So this is it's a corn crop on the left and a sugar beet crop on the right. Um, I just want to touch on the fact that they're um, one of the things my boss used to tell me is never go scout a field at 2 p.m. On in July when it's hot. So for example, what we're looking at here is both corn and sugar beets in the afternoon um, on a hot day, middle of summer. Um, and then here we're looking at those same fields at early morning, whatever time it may have been, 7 in the morning. Um, and so really the point here is just keep in mind there's a difference between drought stress and heat stress. So these crops were not necessarily um, too dry. They were stressed by the heat of the afternoon, and so especially sugar beets. There's some other crops as well, but you'll see that a lot where in the afternoon they'll look really stressed out. It can make you think there's not enough moisture out there, but often it's heat. It's the stomates on the leaves closing and shutting things down. So um, just keep that in mind that it's not always drought stress that we see where it's actual moisture stress. Sometimes it can just be heat. Um, so I guess the big point that I'll make as we go through the talk is just that there are a lot of different ways to measure soil moisture, a lot of different ways to interpret the data. Um, but the real important thing is to just find a technique that works for you or for the folks that you're advising as far as using that technology um, uh, in a beneficial way, and that can be from the simple to the very complex. Let me just pull these up. But so when you're thinking about soil moisture monitoring and about crop water use, there's a lot of different things to consider. There's what's going on with the plant, what type of crop is it, what growth stage is it in, how deep are the roots. Crops can vary anywhere from something like an onion, 12 to 18 inches deep, and then you can have corn down to 4 feet, or you could have alfalfa that could be as deep as 15 feet as far as the roots. And so that's a big important consideration when you're talking about the depth of moisture. Um, uh, Also thinking about crop water use, how much water does the crop actually need and use? And you can look at ET is evapotranspiration, so that's evaporation from the crop and soil surface, but also how much water the crop is actually using, the consumptive use, how much water is the plant requiring to produce um, uh, uh, acceptable yield. And you can look at those that information through weather stations, local atmometers you can do on site. Um, then you also want to pay attention, of course, to irrigation and precipitation amounts, how much water is actually coming back to the system. And then in the soil, how much moisture is in the soil, and what is the water holding capacity of that soil. So different, I'll show some information um, on that, but essentially every site has a different soil type, different quantity of organic matter, and that comes back to how much water the soil is able to hold, and how much water is available to the plant, based on the also the the depth of that soil. So when you're talking about soil holding capacity, soil water is held within pore space within your soil type. So um, it's almost like thinking about the soil as a sponge, and you could have a sponge with um, large pore space, so large holes within there that could hold a lot of water, or finer particled soil where those pores are going to be small. And you think about so the one of the concepts that this is showing is permanent wilting point. That's always been a funny term to me. Permanent wilting point basically means your plant is dead and can't grow anymore. Um, Field capacity is when you have kind of what the soil can hold. And then saturation is when essentially you're completely full on the far right there. And then that water is what plants can pull from. And then at a certain point, there will still be water in the soil, but it is at a point where it is dry enough that the plant's roots are not capable of pulling that soil. And so that's on the far left there, the permanent wilting point, where um, plants are not able to access water, even though there may still be water in the soil. So just a few concepts to keep in mind when you're thinking about soil and soil water, and soil moisture sensors. So volumetric water content, that's kind of the most important term. Um, that's moisture content, again, by the soil volume. It's usually reported as a depth of water, so inches per foot, inches per inch, centimeters per centimeter, centimeters per meter. That's the one where you really know, when you convert to volumetric soil water, that's where you really know how much water has been depleted from the soil, and that is an indication of how much water you add back. Um, but there's also, and so in addition to that, there's matrix potential, soil water tension. So again, thinking about the pores versus the soil particles and water on those particles. Essentially, soil water tension is a way to measure just how difficult it is for roots to essentially pull the water away from the soil. Um, and I'll show some examples of some sensors that soil water tension is a big part of. And then gravimetric soil water is probably the simplest way to measure soil water, and that's um, essentially it's moisture content by mass. And so you'll take a given amount of soil, um, measure that, dry it out, often in the oven dry the soils, and then you measure the soil afterwards. So essentially you evaporate off all the moisture in the soil, and then look at the quantity of water that was in the soil, how much soil was just dry soil matter and how much was moisture. Um, and then it, gravimetric soil moisture, if you have that number, it's useful, but it's much more useful when you are able to have soil bulk density, which is how dense the soil is, how compact the soil is, because you can take then gravimetric soil moisture with that density of the soil and convert that back to volumetric soil water, which is a way to um, really quantify what's missing from the soil and what potentially you would replace with irrigation, or precipitation. Um, Soil type is a very important thing to keep in mind. Um, Generally, we think about soils in terms of percent of sand, silt, and clay. Um, and That's very important. Soil type, I think I've got a slide that'll show you a little bit about what that means from a water holding capacity. But essentially a sandy soil, we consider those large particles. Clay soil, very fine particles, less than 2 millimeters. Um, or yeah, two. And so what that indicates is essentially those larger particles like sand. Um, a large textured soil like that, it won't hold as much moisture. Moisture will infiltrate better, so you can have better penetration of things like rainfall. But it won't hold as much water because if you're thinking about the pore space and the size of the soil structure, in that case, the pore space is much more leaky, for lack of a better way to put it. Um, and then soil structure, so kind of the health of the soil, aggregates, how big are the structure of a soil. We hear a lot these days about soil health, and in terms of soil health, you have more stable aggregates, so you have your soil particles are essentially larger, and hold together better, um, and that makes a difference in water holding capacity. And then soil organic matter. So how much organic matter do you have? The image to the right there, you can see, kind of what a low organic matter, slightly more vulnerable soil might look. And then with high organic matter, you have much more potential for both infiltration and water holding capacity. So just an idea about a few different soil types here. You can see on the left, those are kind of the rough categories of soil type, that you can see, and we see all of these in Colorado. We have a lot of clay loams, silty clay loams, very common, but we also have areas with more of the sandy soils at the top of that list. And if you look maybe at column 2 there, the plant available water. So how much water can the plant get before it's held onto so tightly by the soil particles that they can't pull it? So plant available water, um, you can see much lower in the sandy soils, and then the mix where you have a mix of clay, silt, and so that sort of sandy clay, loamy sands, those kinds of things, you have much higher water holding capacity. So again, that soil type is very important to understand how much water you're holding on to. So monitoring soil moisture is really it's a really valuable tool, and um, it can help you better manage irrigation water, and it can help understand what's out there in the field. This slide I think is important just to keep in mind. So as you have soil moisture sensors and you deploy them in the field, you can be researchers like us that we're looking at every the sort of the minutia of every piece of data. Um, but what's really important, and a lot of the farmers we work with, they look more at the trends. And so you'll see that top line is field capacity, how much water the soil can hold. Down below, unavailable water. So it means, there's again water in the soil, but the plant can't access it. And so you kind of look for trends within that available water piece where um, soil moisture will move up, obviously, when you irrigate or when it rains, down when the crop uses it, and so forth, and it'll create a bit of a pattern. And so paying attention to patterns is much more important than the actual numbers, although the numbers are still valuable. But paying attention to that, the patterns of when is the field full, when is the field dry, that's where you can really benefit from this information. Um, some of the other things we pay attention to is as a water quality program, we pay a lot of attention to what, if you irrigate, what goes below the root zone. The crop only goes so deep and can only pull moisture and nutrients from that given depth. And so you want to pay attention to how the water is moving through, but also as a producer, it's very important to know if any of your water or your nutrients are moving below the root zone, because then it's a loss from a production standpoint. Once it's below the root zone, um, those nutrients can just get, they can get into groundwater or be moved off site in an alluvial system. And so it's just important to pay attention to where water is, and in turn where nutrients are moving in your soil. Um, so with soil moisture sensors, there's tons of different options. I'll mention a couple, but there's a whole bunch of different options these days. Kind of ever changing. Definitely a developing technology. It's been around for decades, but technology continues to change. But it's really important to keep in mind local information, site specific information, like we touched on the crop, the soil type, um, what are you going to be investing from a time and maintenance standpoint, and then also what do you need for data access? There's in this day and age, so much of it used to be manual readings, but in this day and age, much of it is, available on your cell phone, and um, there's remote connectivity to these sensors. You can even link them back to your irrigation system, and some of those have subscription services, some of them do not. So it really depends on what your needs are with these sensors. Um, so with again, as I mentioned, there's tons of different options. There's a lot there. So there's like the feel and appearance method, push probes. That's literally, I think I might have a slide on the feel and appearance method, but it's literally just pull a chunk of soil, squish it in your hand, and see how it looks. Then there's gravimetric sampling, where you pull a soil sample, again, oven dry it, and you get an actual mass of water out there. And then there are capacitance probes. Time domain reflectrometry is what TDR is. That's one of the more accurate but also more expensive um, versions. Dielectric constant, tension, where it's actually measuring how hard it is for plants essentially to pull the water. And then again, many others. So there's lots of different options out there, and none of them they all have their pros and cons. I would say, for the most part, none of them are, you know, um, good or bad, to say that, but they all have their pros and cons. And so it really just depends on what you're after and what technology is available. Um, and then the big one that I always share with producers is just I can promote any kind of soil sensor that I think works well, but the most important thing is pick one that provides information that's actually useful for an irrigation manager, somebody that can actually utilize the data in a way that's actually valuable to them. So that's the most important thing, whether that's as simple as, again, the feel and appearance method to just pull a soil and squeeze it, or something much more complex. Really, the important thing is to take the data that you have and utilize it so that you can better manage your irrigation water, especially in conditions where you're water limited. Here's kind of just an example of what that feel and appearance method is. This is an NRCS, Natural Resource Conservation Service, um, publication. They've been doing this for years, and you can actually get, pretty accurate. Like they're showing in the bottom right there, 75 to 100% available. It's based on soil type again, going back, and it's really as easy as just pulling the soil and squeezing it. And there are some different ways through feel and appearance that you can assess and evaluate, how your soil moisture is. And once you get into the habit of this, you can actually be quite accurate, and very simple. With any soil moisture sensor, whatever the technique you use, even the hand feel method, you want a representative location in your field. So if you have a really sandy corner, or you have a low spot or a high spot, you want to make sure that you're putting sensors in somewhere that represents the majority of the field. You can't put sensors in every corner of your field, and so you want to make sure that you're putting them in a representative location. You want to put the sensors, again, based on need. What exactly what information are you trying to react to? Sometimes you can, if you have a sprinkler, you could put a sensor down as far as you want, really. But if you're only managing your water on a center pivot sprinkler down to 2 feet, then you want your sensors in that zone that you can actually manage so that you can actually make choices. And then the other thing to keep in mind with soil moisture sensors is if you don't put them in correctly, you're not going to get good information. And so the installation part is actually very important to make sure you have good soil contact, and that you're doing things according to the manufacturer of whatever technology you choose. Also, then placement is just important to consider. You don't want to put sensors, for this is an example of a center pivot, but you don't want to put your sensors in a place where, the pivot will stop and drain out. Obviously, that would give you, false high readings as far as soil moisture goes. And you want to put it again in the appropriate locations as far as soil type and condition. Um, as a reminder, so no sensor really directly measures soil moisture. It's either through soil tension, electrical indicators like dielectric constant, neutron probes use an actual radioactive source to come back. And so you're not really directly measuring soil moisture. You have to calibrate to really understand what the data means. And again, looking for trends is a valuable thing. Looking for high moisture, low moisture, and what that looks like as far as trends go. And then just understanding that this is just a piece of the field where the sensor is. It's never, it's not going to be representative of the entire field, but placement can help make that much more accurate. I don't think I will spend time on this, but just this kind of a quick reminder of the concept, different types of soil moisture, and then that soil tension there on the right. And just kind of an indicator of kind of the ranges. This is just kind of an example, right? This doesn't show you soil moisture content, but it shows you the concept of how these different indicators, in this case, it's soil tension, relates to that column on the left as far as what the crop might be experiencing. And then I guess the key points, anything is better. I mean, that's one of the values of soil moisture monitoring is, again, you can use any technology, but using anything, even the hand feel method, is better than doing nothing and just turning on your irrigation system. Use technology that you enjoy and technology that you will use. Make sure that it is properly installed. And then again, look for patterns in the data and look at data critically. If it's not telling you something that makes sense, it's probably an issue with the sensor or with the associated data. And with that, I think it might be a minute over, or two, but I will stop there if there's any questions, or otherwise, please, my contact information's there on the left, and please feel free to reach out or ask us any questions. Obviously, this is a quick run through soil moisture sensors, but we have done a lot of work on these sensors over the years, and we're more than happy to help provide any feedback or guidance if folks have questions.